Welcome to the Amp Hour. I'm Chris Gamble from Chris Gamble's Analog Life. How you doing today, Dave?
This isn't Dave.
Who? What? Where's Dave?
It's not Dave. Yeah, I think you must have called the wrong guy this week.
Oh my God, who did I call?
It's Jeff Kaiser again, Mighty Ohm.
Oh, hey Jeff, how you doing, man?
Hey, pretty good. How are you doing, Chris?
This works out well because Dave's actually on vacation and he can't talk anyway, so what a weird coincidence.
Yeah, that's really, really strange.
Yeah,
but, it's good to be here again. I guess, no notice is better than no notice.
Yeah. yeah, that's right. So, well, thanks for coming back. I think we had really good response last time you were here, and I don't know.
Yeah, well, I'm happy to hear from you again. I guess it means that the last show didn't go terribly wrong.
No, it went pretty well, actually. We got a lot of... I don't want to talk about the Uno again. I mean, we talked about...
No.
I think
definitely...
we beat that one to death.
Yeah, and I think I talked all I ever need to talk about the Arduino Uno ever. I mean, I just said it there. That's probably
Oh,
enough.
God. Yeah, what are you getting,
for the show.
Getting it for the word? Like Massimo Bonzi is, throwing you a couple bucks every time you say it.
So where's Dave?
Dave, I think he's in the middle of, forest in California.
Oh, I think he's in the Sequoia National Park.
That's right. Yeah, he had that on Twitter today, or the other day.
Yeah, I saw that.
He's not around, and...
Yeah, actually, one of the things I saw that he tweeted about, if I can interrupt for just a second.
No problem, man.
And this, you can stop me if this goes off on a tangent, but I saw that he has been all over California, and it looked like, I guess he was there for a Renaissance conference, right? Some kind of a seminar or something, and I didn't get a chance to watch his videos on that, but I did watch his Twitter stream, and I saw he went to one of my favorite places in the Los Angeles area, which is Apex Electronics.
That's right, because you used to live around there, right? Or you lived in San Fran, right?
I used to live in San Francisco, but before then I lived in San Diego, which is not too far away. But I have a good friend that lives in the Los Angeles area, and I actually went down, I guess it was about a year and a half ago, with the express intention of visiting some of the really cool electronic shops that are in the Los Angeles area.
Now, that's crazy, because I would not have thought that LA would have electronic... I mean, you think LA, you do not think electronic shops.
LA has everything. If you're into do-it-yourself anything, I can pretty much guarantee that LA's got it. I mean, there's stuff for people that do woodworking. There's stuff for if you do metal shop, you can buy surplus materials. And this friend that I've got down there is into the electronic scene, and I've known him for a long time. And so he knew all the places to go that were in Los Angeles. And so we actually went on a weekend, and I flew in. And this is whenever I was working on that Wi-Fi radio project that I mentioned last time. Yeah, so he did the woodwork and did the really nice case. And so we actually went to a hardwood veneer shop and bought the veneer. And that was really awesome. But the best part was we got to go to some of these electronics surplus shops, which, as I think the Bay Area has quite a few, or there's still a few left. There used to be far more. And these are places where you basically can buy electronics junk. Most of it for the price of the metal. So really a deep discount. And so one of these places is called Apex Electronics, and I can't remember exactly where it is. It's somewhere north of LA. And it's the kind of place where you can buy used vacuum tubes and wire and meters, but then they also have weird stuff like bomb casings, and I've got a couple pictures on my site of whenever I went there, and hopefully Dave took some video.
He said he did, yeah. So that'll
awesome.
I think he mentioned that it was going to be like the Akibara tour. I think I'm saying that. I hope I'm saying that right. I don't know if I am, but
I don't think it's quite the same thing. It's not a city devoted to electronics.
It's more like a junkyard.
No, that's actually exactly what it is. It's a junkyard devoted to electronics components. It's really amazing.
LA wants your crap. That's right.
Yeah, and actually, the interesting thing about it is that I think the reason that Apex stays in business, and I could be totally wrong about this, so someone please correct me, but if anybody knows the Apex guys, I think one of their biggest customers is Hollywood, because all the stuff that's there, and if you look at the pictures online on the Apex Electronics site, or if you look at Dave's video, if he posts it, you'll see that everything just wants to be a prop in a movie or something. It's just you can get all sorts of mad scientist kind of stuff and all
awesome.
sorts of neat things. And I think it's really cool. So I'm definitely looking forward to seeing what Dave recorded there.
Yeah, that's great. I imagine like maybe he'll be able to find like how they in Back to the Future 3, he's a big Back to the Future fan. How they replaced the microchip with like all those vacuum tubes on top of the DeLorean.
yeah.
That's what I imagine when you say like the props that you would get there because it was
absolutely
all tube based and everything.
That's exactly what this place is, and there's actually some other places like it, but I don't know the names of them.
Yeah.
I know the equivalent in Silicon Valley, which is Weird Stuff Warehouse in Santa Clara or Sunnyvale, I guess. The same kind of place. Like you can wander there for hours just looking at weird, kind of semi-useless junk. That to the right person, I guess it's worth a lot. Really cool stuff.
That's awesome. Well, let's move on to the shout outs. We don't have any this week, but one that I wanted to give a shout out to is Chip Hacker. So you said you didn't know what chiphacker.com was.
I don't think I've ever been there.
So it used to be chiphacker.com, and recently there was Chip Hacker and another site, and I think Electronics Exchange perhaps. But basically, they merged, and now they're Stack Overflow, that site for programmers.
I'm not familiar with it.
No, okay. So basically, Joel Spolsky and I think that's how you say his name, and a couple other people, they started up a new type of forum, and it's this really great way of doing it, where it's it's merit based. So the more you post, the more rights and privileges you get. The more you get. The more people you get there, the more expertise. Obviously, that's any board, right? But I really like the format because it's kind of like combining a wiki, it's combining a message board, it's combining like a Reddit style voting system, and it's just this really awesome way to get information. So anyone out there listening, I would highly, if you're not already looking at it, it used to be chiphacker.com. If you still go to chiphacker.com, that'll work and take you there. I'm not sure how much longer they'll maintain that, but now it's electronics.stackexchange.com. So
yeah, I've just got it open right now, and yeah, it's kind of a neat idea because the people that have the most interesting questions and projects get voted up in the list, and so you kind of get to see really cool things, and it's not just one person posting, but it's like a discussion about what they're working on.
Yeah, and I've used it recently for personal projects, and the really nice thing about like a Stack, I think Stack Exchange is the actual open source software that runs the actual message board. It used to be called, I think the Stack Overflow is the one that was the initial one, but then once they developed it enough, they actually opened it up to the community, and now you can download it and start your own board, kind of like a Wikipedia.
Wow.
I totally forgot where I was going with that. Yeah, that's what it was. Basically, it's really nice because there's a lot of mechanisms in it to have a really broad range of experience. So, a lot of people that are beginners would often... you don't want to. You either got to go through and open up everything and try and find your answer, which is always a good idea. You're going to get in trouble if you don't actually try and search for it. But the thing is, even with beginners, they're very much encouraged for the easy questions to be asked there as well. Once you've searched, whereas on a forum that might be a little bit more looked down upon. There's always different levels of forums. You know what I mean?
Oh yeah, you got to watch out for those forums where if you're the noob,
exactly.
You get yeah.
So this plays really nicely for having that broad range of experience, where you'll have people that are, and because of the voting system, it'll bring the more experienced answers to the top, and if you look at it, you're always going to see the most experienced answers at the top. I mean, so. It's very nice in that regard, and yet you can still add in. You can comment on answers. And you can comment on the question even, like, oh, this shouldn't be here. You can, if it's a community wiki, it can open up and you can actually modify it if you have the privileges. And much like Foursquare or a lot of other people are doing this now, they have badges too. So if it's really interesting psychologically. It doesn't seem like that would really do much for you. It's like if you get a badge, who cares, right? But at the same time, it might start motivating you towards certain behaviors. So if you're supposed to, if once you get the privilege to edit, if you actually go and edit something for the better, you might get a badge for that, you know? And so it actually encourages involvement, like, and there's like different levels and blah, blah, blah. Not necessarily, you wouldn't go there just for that. You go there for the electronics knowledge, but it's very good. And if people out there listening have never been there, once again, it's electronics.stackexchange.com or chiphacker.com for the time being. And I like it a lot. And the more people that are there, just like any message board, you know, it's, yeah. So I love it. And
yeah, very, very cool. I'm reading through it right now, and there's something for everybody because they've got a lot of questions or topics about microcontrollers. There's soldering, surface mount electronics. Somebody's asking what the cheapest TQFP44s and SO28s are to practice SMD soldering, and there's people telling them where to get cheap parts. So
yeah.
It's cool. It's like any question, no matter how obscure, has some answers, and it seems like people are being genuinely pretty helpful, which, you know, in forums sometimes you don't get that as much. This looks really cool. I'm definitely going to check this out.
And you know, I've asked the question before in my blog about, you know, where do you really go for some of this stuff? Because a lot of times it's not out there. You know, like or it feels like it's not out there, or it's fragmented. You know, like there's you know, like Dave's site, EEV blog, they have forums. Adafruit has forums. I think your site has forums.
Yeah, I've got forums, but they're fairly small, just because they're only to support individual projects.
Right, and you know, it's nice because the software that's out there is very, you know, people know how to use it, so that's good. So that's kind of a downside for this new Stack Exchange thing. But at the same time, I think, you know, if there actually was a centralized point to go, because of the system and how well it's developed by all the Stack Overflow guys, I really like it. So hopefully more people will keep coming there. You know, I'm not saying to desert your favorite board. I think All About Circuits is another really strong one. AllAboutCircuits.com is a really, really big board. But again, you know, there's always super users, and there's cultures among boards and stuff like that. And sometimes it's okay to ask one thing versus another thing. And
yeah, and you know, you'd be amazed at how many obscure forums there are out there too, because I've done searches on Google for obscure things like land patterns, defining your own land patterns in Eagle, and wondering about what the rules are, because there's all these rules in defining optimum land patterns, and you get on some weird CAD EDA board that's all professional engineers, and it's amazing the stuff that's on there, but it's a very insulated environment, because that information, if it weren't for Google, I would never even know that this board existed.
Exactly. Yeah, why would you ever go and join that? Because it's like, you always need some level of involvement in order to keep up on it, right? And you don't want your email flooded with, you know, oh, well, Mike from, you know, Sweden needed some help with, you know, X project that I don't even care about, you know? So, but, you know, you could have that too, and you can set up tags and stuff in the Stack Exchange. So hopefully more people will be going there in the future and keep on building it up. What else was on the list for today? Let's see, I've lost the list already. Well, we were going to talk about some of the sourcing issues that are out there right now.
Yeah. I just wanted to go on a little bit of a rant about it.
It's okay, go for it, man.
well, I guess
let's get a background first, I guess.
Yeah. Well, I don't know if you want to talk about it. It's you say you've mentioned it on the show before, so.
Well, just sourcing issues in general. I mean, like, you know, for people that are starting out with electronics or you know, or even have been in electronics and maybe aren't in industrial, not even industrial, but like commercial situations, sometimes you don't really realize that getting 5 parts is okay from DigiKey or Mauser or whoever, but getting 5,000 parts is often very much more difficult. But it sounds like you have been having problems getting the 5 parts even.
Yeah, absolutely. And I was talking about this online this week because I've been having a real problem getting a hold of Atmel AVR microcontrollers. And it's not just something that's been going on this week, but it's something that's been affecting me basically for all of 2010.
Yeah.
And the issue is just that some of the very popular hobbyist micros in the AVR line are not available. And it's not just DigiKey, but it's everywhere. If you go on Fine Chips or if you go on Octopart, you turn up all zeros. And this is for all the major parts, like the Atmega 328s are usually out of stock, although they get little bits here and there. But just this week I was looking at Atmega USB chips, the 8U2, yep. The 16 and the 32U2 and the 32U4. And the delivery dates on these guys are out into next year, in 2011, for pretty much all of them. And I think that the only reason I really bring it up, and I think the reason why this is important, is because it is just the 5 chips. If you're trying to make a prototype using an AVR microcontroller, you have to be very careful about which variant you pick, because many of them showed lead times in like the tens of weeks. It's not it's not just next month, but in a lot of cases there won't be micros available for 6 months. And so for someone like me who's go ahead.
Oh yeah, I was thinking the like a couple months ago, even though they were saying into 2011 for certain things.
Yeah, no, absolutely. There's some parts that have been very hard to get a hold of pretty much all year. And so what I think a lot of people are doing, and I'm guilty of this as well, is stockpiling parts, which makes it even worse, because then whenever the parts do come in, they get gobbled up by all these people who may or may not actually need them for a project that they have today, but they're worried that they're not going to be able to get them tomorrow. And so it's a real problem for people like me who, I do freelance electronics design, and I do kits, and I do a little bit of everything, and how am I supposed to keep designing circuits around microcontrollers that I can't get a hold of?
Yeah.
And in my case, it makes me start thinking about, maybe I should look at MSP430, maybe I should look at PIC, maybe I should look at something that I can actually get parts for. But I'm so committed to the AVR platform that it's really painful to think about switching. I'm all geared up for AVRs. I like AVRs, and now I'm getting punished, basically. And I'm not really sure what the cause of it is. I've heard a lot of rumors about fab capacities and Atmel having issues, but I'd appreciate knowing what the real story is. So, if anybody knows what's going on in Atmel, or knows somebody at Atmel, throw a little bit of information our way. We'd love to hear about it.
Right. Yeah, and it's not just micros either. Today I was looking at this EE Times article about FPGAs, which have been having a really hard time lately too. I've had that personally. Actually, it's kind of funny because the title of the article is "Analysts Fret Over FPGA Lead Times," and it's for completely the wrong reason, though. They're fretting because the lead time's going down. So they're all worried. They're all worried demand's taking a dive, and it's like, screw you guys. I want some parts, screw you.
We need to write a column. Engineers concerned about it.
Engineers concerned about stupid analysts who want to make more money. We need some parts, dum-dums.
I can't. There are a few things that are more frustrating than to have a circuit that you love and that you've put a lot of energy into, and then to have your supplier tell you that you can't build it because you can't get the parts.
Yep.
It's like the carrot dangling in front of you, but you can't actually grab it.
Right.
That's how I feel sometimes. And you're right. It's actually a lot of things. And I feel like the availability for a lot of components has actually gotten better from early in this year, whenever it was hard to get capacitors and LEDs and things that.
Yeah.
So it's really interesting. But I'm happy that I don't have to deal with that many different product lines, because it's one of these things where the probability of being able to make a complete complicated PCB where you have maybe 100 different components, if any one of those components goes unavailable, you're hosed. And I had that experience this year on a contract I was on, where I needed to build more boards, and I couldn't. And it's because out of 200 components, there was one component that was unavailable, and so I couldn't build the entire board. And in this case, it was an RS-45 converter, and I was able to find a substitute, but it's things like that drive you absolutely crazy.
Yeah, I'm always pushing vendors. First thing I always say to them when they're developing a new part is it a standard pinout? And they always kind of hem and haw, like, oh, well, we have our new package technology. It's like, I don't care. I want to be able to rip your part out at any time if it pisses me off. So if you're a vendor, design. And the real problem is, I think, for like the analog stuff that I'm using on a regular basis, is it's getting so small that it's almost impossible to standardize, and they've started patenting their stupid little package technologies. I know there's a whole science behind it, but I don't care. I want parts with standard pinouts. So someone step up to the plate. I don't care what it is, if it's LT or ADI, and say, here's the standard. Maybe even IEEE should start jumping into this stuff, because it bugs the crap out of me. And I would buy more parts if they were. I would definitely target parts that are standard pinout and then go for the specs after that.
Yeah, because you want to be able to second source, and maybe these days you want to be able to third source things, right?
Yeah,
you want to have a backup plan. And I think this happens to anybody. It happens to big companies too. They get hooked on these particular parts, maybe because a particular supplier offers something unique, and then you're exactly right. It comes in some weird, obscure package, and then whenever the parts are not available, you're screwed.
Yep. Yeah, and it's gotten to the point where the design I'm working on most recently, I've been on DigiKey and Mouser and Octopart and all those, and I just sort descendingly by stock, and even though it's not reliable because someone could come in and buy all of their stock out because people are doing companies are doing that. That's still the best that I have in terms of a prediction mechanism. So, the number one, and the worst part about that, since you got us on this rant, Jeff, the worst part about that, what I've thought of, is what if no one's buying these because they're crappy parts? Oh my God, what if that's actually the reason? I mean, I don't think it always is the reason. I think sometimes it's just certain suppliers are better than others, but, that has crossed my mind that I've been buying crappy parts because they're available.
Well, yeah, I know what you're saying, and I usually have a pretty good nose, and I spend a lot of time on DigiKey's site, and I filter by in stock, and I usually filter by RoHS also because I want lead-free, and that usually cuts the available parts down by a factor of 10 just by checking those two boxes. But it's interesting because you can usually tell if a part, like if they have 35 units left, that makes me nervous. If they've got like 80,000, then usually, if it's 80,000 and it's a low-cost part, I usually feel pretty good about it. But there are certain combinations of factors that kind of raise my suspicion that maybe it wouldn't be a very good idea to design a board around this particular part.
Yeah. Yeah, it's getting. I mean, I hope it keeps getting better, but until then, it punishes those with bad fab capacity. It punishes those with outsourced capacity. So people that are doing the TSMC, the fabless design. So that's on the micro side. So people out there listening that don't know, some companies are actually, they design in-house, so they might actually, so say you're designing a new FPGA, like an Altera or a Xilinx. I think Xilinx has their own fab, I'm not sure if Altera does. But say they design this FPGA, they have all their simulations on their computers, and all these gate counts, and they design all this fancy stuff based on the software, and then they just ship it over to TSMC, which is Taiwan Semiconductor Manufacturing Company. And, that is the biggest fab company in the world, followed by Intel, I believe, and then followed by Samsung, or, all three of those are the big players. But basically, everybody puts their stuff through these chip foundries, and now you also deal with, Dave and I have talked on here before about how the Apples of the world get all the priority on parts. Well, not only that, now the people that are making the parts are also giving priority to the people that are selling the most parts. So if National Semiconductor is selling all their parts to Apple, so Apple gets 100,000 parts from National Semiconductor, and then National Semiconductor is in charge, or is in front of maybe ST Mike. Well, no, ST has their own capabilities, I think, but is in front of some other company that's doing very similar things, and now the people way at the bottom, we are back at the line basically, and we are getting no parts, and it's like, luckily DigiKey and Mouser and all those guys are big buyers because they buy them in bulk and then they sell them to us for a 50% markup. But it's
that's right. Yeah, thank God for them.
Yeah, I am so appreciative. Thank you, DigiKey. We love you. Oh, so awesome.
Yeah.
That's great. Looking on like a vendor site, they're like, 1,000 piece price is like $2. Then you go to DigiKey and it's like, oh no, they were saying $7. That's what they really meant.
That's right. That's right.
Screw you guys.
Yeah. No, it is a real problem, and I think that as hobbyists, people like me that actually are not just hobbyists but small businesses, that's the real. Those are the people that get really hurt by this, because we don't have the volumes and we don't have the units to be able to get the quantities that we need. We're not even on the radar for these companies, and I think that's the thing that's affecting a lot of the especially dip packages of anything these days, because I think the only people that use dips are the small companies and hobbyists for most parts, and so we get basically whatever's left over.
Yeah, and there's a bigger market for that now too. I mean, a lot of people have. I think SparkFun has a bunch of breakout boards, and Adafruit has a bunch of breakout boards, and I've seen some elsewhere too. And I think there's a market just for that. I mean, I've seen industrial socket designers too that do the same kind of thing. So if you're out there and you're thinking about, well, what kind of company should I start? That could be one of them. Honestly, that is a big need, because it's a silly little thing, and you'd have to buy 10,000. You'd buy a couple panels worth of PCBs and get 10,000 pieces out of it. But, eventually you make your money back because it's necessary, and it's going to keep happening. The dip is nice to have because it's pluggable, and it's going away, like you said. So we'll see what happens in the near future. I mean, not near. I don't know if it's near future either. I think Atmel said they are going to keep it for a while, right?
I think so. I mean, I don't know. I hope that they'll tell us well before they discontinue it. But I think it's probably something that they're not in. They'd probably like to get rid of it, but maybe there's enough people asking for it that they don't. Yeah.
Well, there's always those legacy issues too. I mean, there's products out there that the military buys it, components, and they buy products and they want the same components in them for 20 years at a time. So
sometimes that happens. I will say that most of the more interesting parts are not available in DIP. You tend to be fairly restricted for the features, because even in some DIP packages you'll get less features than you do with the same part in a surface mount package, just because the DIPs don't have as many leads. But they're easy to use, they're easy to test, and for people that just want to throw something together like a prototype, it's hard to beat the dip.
Yeah. So what about the lead-free you were talking about earlier? You said you do your boards in lead-free. Is that a design requirement for you, or is that a personal choice?
It's actually for me it's both. For boards that I've done for contract work, I've been actually required to deliver lead-free boards by my clients, and usually it's because the board is not just for the United States market, and so if somebody wants to be able to take something that I've worked on and then be able to sell it overseas, there's requirements for lead-free assembly. But I also feel that if possible, it should be a goal to try to make things lead-free. I think that these days it's fairly easy to get pretty much all the components lead-free. Like, if you actually look at DigiKey, by choosing lead-free, you usually don't eliminate very many choices unless it's an old, obsolete component.
Right.
Most components coming from the manufacturers are lead-free anyway, because there's a lot of pressure on them to be lead-free so that they can sell their parts in world markets.
Yeah, exactly.
So really, I mean, how much effort is it to go lead-free for your final assembly? Well, you have to use lead-free solder.
See, now that's where I'm going to stop you. I knew you were going to get to that point. I'm going to stop you right there. I hate lead-free solder.
Why do you hate lead-free solder?
It takes the higher temperature. It doesn't flow as much. I mean, I understand lead is a nasty thing, but I love my leaded solder. I don't know if I sound like an old codger right now, but it's just a superior product, I think.
Well, it certainly is, but not if you think of the big picture. I mean,
I agree with that.
Yeah. I mean, it's easier to work with. It wets better. But I've actually found, and I was one of the people that resisted using lead-free. But I actually had someone kind of force my hand into just giving it a try. And basically, I was working somewhere where there was absolutely no leaded solder anywhere in the lab, and so the only option was to use lead-free solder. And I actually found that the lead-free solder that you can buy now, and I can't remember which specific alloy it is, but it was your ordinary lead-free solder on a spool.
Like some silver tin. Is it 70-30 kind of thing?
No, it was more. I think it was what was it? Tin, silver, copper, and I'm probably completely wrong about that. But
we do electronics, not materials. Blah blah blah.
No, it's actually an alloy of 3 metals, and it's one of the most common. And I wish I could remember it, but it's been a while since I looked at the label. But it's the most common kind if you buy solder from any of the major distributors, and you pick lead free. But the thing about it is that once you get used to it, which means having a soldering iron that has an adjustable temperature, and if you're doing like a hot plate, you need to be able to turn the board up a little bit hotter to get it to reflow. Your reflow toaster oven has to be a little bit higher. But once you make those adjustments, it's really not that hard to work with. And I've found that if there's any kind of a problem, usually a little bit of extra flux, for the prototyping kind of stuff, you can get away with that. You just add some flux, and then it usually flows, and it looks just as good as leaded solder. So I have to say that coming in as a skeptic that it was going to be a nightmare, I actually am not scared of it at all, and I can use it interchangeably without really having much of a problem. I still use leaded solder for some of my personal projects, but pretty much anything that I work on for a client or anything like my kits, I assemble entirely lead-free, just because it's not that hard to go that extra mile. And then it makes me feel a little better that at least if I'm shipping kits internationally, I'm not sending them lead-containing parts, which you're not supposed to do. And I'm not actually completely versed on the requirements, but it's my understanding that if you're making stuff and you're sending it to Europe, that you've got to be RoHS.
Right, and I think RoHS is getting more stringent now as well. I know I saw something about that the other day. It was a couple weeks ago, actually, and they're adding a couple more chemicals to the list. I think they've got the solder thing down pretty well. And for all of our listeners out there who've given me crap before, solder.
Solder.
I catch that one pretty regularly from a friend in New Zealand. So
yeah, us Americans like to say the solder and
solder.
Solder. Yeah.
Yesterday I was going down to the supermarket and picked up some solder.
Get some solder and have it yard.
Yeah. No, I don't go there.
Yeah. I know what you mean, and I just saw something not that long ago, and I can't remember where I saw it, but they had just added another chemical to the prohibited chemicals list, and I can't remember what it was, but it's funny because they slash these chemicals off the list, and then you have to think about, well, what are all the things that use these chemicals that now are going to have problems? And I think that whenever they first introduced a lot of this stuff, it was really hard for manufacturers to comply because electronics have always contained all sorts of interesting, brominated epoxies and things, fire retardants.
That's a nice way to say it, is interesting.
Well, not the kind of stuff you'd like to put in your body, I guess.
Yeah. Trying to find the chemicals right now. I know there was one on there that I had definitely used before. It wasn't sulfur hexafluoride, was it?
I don't think so.
SF6?
I think it was something more basic, wasn't it? Like cadmium or something. It was.
Oh, cadmium's nasty. That stuff will poison the crap out of you.
Absolutely. Absolutely.
I think SF6 actually is on the list. Have you ever seen that stuff before?
No, I have not.
That'll be a great thing to link in. We always have links on the page, but SF6 is it's a gas. It's an inert gas, and I used to use it. I used to work in a fab, and I worked in dry etching. And so people who don't know what that is basically when you're making a micro or a silicon wafer, and you're trying to etch patterns onto it. First you lay it on photoresist, and then you use light to expose it. And then you use chemical etch. You either use chemical etching, which is called wet etching, or dry etching, which is like you create a plasma with like RF energy and all this crazy stuff. Well, that's one of the chemicals we used to use. It is pretty common throughout the industry. But if you look at videos online, and it is pretty nasty once you actually like hit it with some RF energy because it breaks off all the fluoride ions and free radicals, and it starts to eat at the actual wafer. But if you look at the gas in a natural state, it's actually heavier than air. So there's a video on YouTube. There's a couple of videos, I think, where there's two things you can do with it. Neither of which I would suggest, because I still wouldn't play with the stuff if I had it. One is if you put SF6 into a tank, like a fish tank, you can actually. They have a video, and there's a tinfoil boat that's floating on top of it, and it looks like it's floating on nothing because
I have seen this. Yeah, I have seen this video.
Very dense gas, and that's why it happens. Yeah. So it sits in the bottom of this container, and it looks like it's floating on nothing. Yeah. Very cool. The other thing that you can do with it is, much like helium raises the pitch of your voice, SF6 lowers the pitch of your voice, and
but you wouldn't breathe this stuff.
Oh yeah, they do.
Oh wow,
it's inert in a normal state. I mean, there will be some natural radicals from like gamma radiation or whatever's coming through the atmosphere, but like I said, not the healthiest thing to do. Just like helium, like whenever you suck in helium and make a funny high pitched voice, not a good thing either. But seeing someone else do it on YouTube, that's always acceptable. So I'll be sure to link that in too. I think that's on that Rojas list. I think that's on some list, and there's a lot of chemicals out there that are pretty nasty chemicals. So it's that's one of them. I mean, it can be very nasty.
Yeah, that's interesting. I didn't know that you worked in a fab. That sounds like a pretty cool job.
It was all right. It was not as electronics oriented as I wanted it to be, so that's why I kind of got out of it. And
I actually had a chance to visit a fab whenever I was working in California, and it was actually the same fab that's in the Postal Service Such Great Heights video.
Interesting.
There's a music video, and it's by the Postal Service, and it actually, the whole video was filmed inside of a fab in Newbury Park, California, that I had the privilege of getting to see the inside of. And my biggest beef with it was that it took me like 20 minutes to get suited up to go inside. And it was so hot inside the suit that I had to wear that I was constantly fogging up my glasses.
Oh, yeah.
So maybe I'm not cut out for work in the fab. But it was fascinating to see everything that's in there. And they were showing me ampules of gold that they use to do sputtering and all sorts of stuff. It was really, really cool. This was a gallium arsenide fab, so it's a little bit different than what you used to work with. But really, really cool stuff. And the number of amazingly dangerous chemicals that they use is really mind-blowing.
Oh, yeah, definitely. I recall not so fondly seeing pictures of what hydrofluoric acid would do to people.
Whenever I was
part of the training.
in university, they told me not to spill that because I guess it goes through your tissue and eats your bones on the inside.
It actually eats the tissue from the inside, so you'll spill it on yourself. You won't feel it, and then your hand will start to rot off while you're looking at it.
Wow.
It's like a chemical burn that comes from the inside. So if you even think that you've had it splashed on you, they'll put this copper paste and it leaches it out somehow. And
you probably made probably 3 listeners that work in fabs just considered leaving their risky occupation.
Oh, I'm sure if they work in a fab, they know about it. I guarantee you that.
Okay, good.
Yeah, it's good. It's really cool in there, and I like the people I work with a lot, and it was a really cool experience. But like I said, fab life is a different life, and if you want to do it, if there's people out there considering it, definitely try it out. But I was working in a manufacturing capability. I was not doing any research in there too. So that's another, I'm sure that gallium arsenide fab you went into was very research oriented.
No, it's a production fab.
Oh, okay. Well,
it is. They use gallium arsenide is used in most
RF,
high power RF chips, and so this is a fab that actually cranks out parts that are in a lot of cell phones around the world. And so it was kind of cool to just be amidst, and that's actually one of the things you were talking about TSMC earlier. There are not very many gas fabs outside of the United States, and so gas is one of those things where you still have a lot of manufacturing activity going on within the U.S. And I know there are fabs outside of the U.S., but it's not like silicon where most fabs are not located in the United States.
Right.
So it was interesting to actually walk around in a place where they're actually making volume, and it gave me an appreciation because as an engineer, it was very easy to yell at the guys in the fab whenever they screwed something up, like patterned a wafer wrong, or the worst one was whenever they dropped things because gallium arsenide wafers shatter. And so you end up with a million little bits, and maybe you get one or two of your chips off of. But it gave me a new appreciation for how ridiculously complicated and difficult the job that they had to actually make those devices were. So you don't really appreciate that until you go there and you see that.
Yeah. There was a really interesting comment. I'm not sure where it was on. It was on the suggestions maybe of the Amp Hour page. And someone actually suggested that, Jerry Ellsworth started doing MOSFETs in her house. And
yeah, I'm familiar with this. She was, and you should post a link. She's got some YouTube videos, I think, about it.
Yeah.
She was actually making FETs in her garage, and she was using household chemicals, like the kinds of things you'd get at Home Depot. It turns out you can buy dilute hydrofluoric acid at places like Home Depot, which is a hardware store for anybody not in the U.S.
Oh yeah, good point.
But you can go down to your local hardware store and you can buy things that contain. I think she was using stuff that contains arsenic and phosphorus, and she was basically getting dopants out of household chemicals, and she actually patterned some FETs, and they worked. So that was really, really cool to see. I actually got to see that at the Maker Faire last year. She was there.
Okay.
And I think it's a far cry from having a home chip fab because she was making just a couple of devices. But it's interesting because whenever you think about it, at the beginnings of the semiconductor revolution, people were working out of what wasn't really much more than a garage.
Right.
So I always like to think of things, if you trace things back far enough, there was a point where a guy was doing that in his garage. It's funny how far away we get from that, but there was a time whenever it didn't take a lot to make, fairly low performance devices, but I think it's interesting because people like Jerry are trying to retrace those steps.
Right. And the thing I was going to bring up too is that someone had mentioned, I'm trying to find it right now. They mentioned the fact that this actually might be possible in terms of like photoresist etching and stuff like that. Like I think he said, I hope I find it too. I'll at least post the link. But basically, modern laser printers have decent resolution down into the micron. 20 micron, I think he said was the lowest resolution you can get right now. And that's a far cry from where they are now. 20 microns is 20,000 nanometers. So they're rapidly approaching 1,000 times smaller than that. I think the smallest geometry they're producing right now is in 30 nanometer for like the Intels and the Samsungs of the world are doing like very small flash memory and microprocessor CPUs or whatever. But basically, if you're starting to start moving up in the geometries, this is actually a possible thing to do, and it's a really interesting notion. I had never thought of that before, but much like we can do the like the ink hack where you can print out a piece of paper right now and then kind of push that onto a piece of copper and then use that as your etch resist if you're etching a board at home. Have you ever done that at home?
No, I haven't. I've always kind of avoided it just because of the chemicals.
Not worth it. Right? Yeah, I agree. But I've seen that before where people can you can actually print out. You can print out your pattern on just a regular paper. Then you kind of transfer it over to a copper clad board with like FR4 below it, and then you just etch the copper. And to be honest, folks, that's basically how you make a semiconductor, just on a much, much smaller scale.
Yeah.
And you layer it too. You got to layer it and grow stuff and dope stuff. So obviously there are a lot more steps, but you need a furnace. That's maybe one of the hardest things about it. You need to be able to get things really hot. No, I mean really hot. I got 2 ovens.
Well,
I don't have 2 ovens, but you know what I mean. Like I think that eventually there could be, much like there's laser printers or laser cutters now that are open source, and there's the 3D printers that are open source. I think it is possible that eventually very stupid chips could be made at home. Jerry started on that path, but I think that in terms of
I've actually thought about this a bit over the past few months, and one of the things that and here I go, I'm going to be talking about these hacker spaces and things like that. So I guess whenever I'm on the show, it kind of the topics change a little bit to
that's okay.
more of the open source hardware, you do it yourself kind of stuff. But I think it's interesting to start thinking about what would happen if do-it-yourself people, hobbyists, people in hacker spaces started thinking about making their own chips. And what I'm actually talking about is not making them at home in your garage, because to me the cost in equipment and chemicals and all that and the hazards of working with these things are kind of a problem. But there are services which traditionally universities have worked with to make chips, and Moses is the most famous one. That's where a lot of students that are in undergraduate or maybe grad school. I never got a chance to do it whenever I was in university, but you get to make a chip, and it's like a 3 or 6 month long process of designing the chip, laying it out. And interestingly enough, a lot of the chip layout tools are open source. So there isn't that exactly, because all you're really doing is putting down squares to define gates and things like that. And you can get some sort of okay simulation tools now, and so it would be interesting to think about actually having a group of hobbyists or maybe small businesses, people that are entrepreneurs, basically pull together to get a mask actually fabricated. And Moses, I think, is in some fairly decent processes. It's not like the latest stuff, but you don't really need the latest and greatest things for most designs that you'd want to do, especially if you're working on analog circuits. Those tiny gates are not helpful for analog. They actually hurt you more than they help you.
The leakage.
Yeah, and also voltage range and things like that. The breakdown voltage is really, really low for those advanced processes. And here, we still like working at 3.3 and 5 volts, right?
Heck, I like higher than that, I'll say. I love plus minus. If those vendors out there that are making me standard pinouts, if they also want to give me plus minus 15 rails, I will take them. So just a side note there.
You like the op amps from the 70s and things like that, right?
Let's say the early 90s. Let's say early 90s.
Oh, okay. Well, so I think it would be interesting just to see what would happen if you enabled people to make their own chips, and even though it's not at home, it's kind of the next best thing. Think of it like batch PCB, but for integrated circuits. And the costs are quite high. It ends up being, I don't know, it's in the tens of thousands of dollars. So it's not like the affordability is there, but I start thinking about, well, so if you had this capability, what would you do? And I guess I'm not entirely sure, but it would be interesting to make some very highly integrated circuits that you couldn't do using traditional ICs. Like, there's a lot of RF circuits you could make that if you had access to your own IC process, you could integrate an entire radio on an IC. So there's things like that I think would be interesting to play with. So I don't know how practical any of this is, but this is something I daydream about. And it'd be interesting to see what happens down the road as there was probably a time whenever printed circuit board technology was considered totally out of reach for the hobbyist, where something like batch PCB would never have existed. So, what if down the road we have, I don't know what you'd call it, batch silicon or something, where people can actually do their own designs.
You can call it batch C. Batch C. That doesn't sound right, no.
No, maybe not. We'd have to think of a catchy name, otherwise it'll never.
Yeah, of course. Who else would
on.
do it otherwise, right? Yeah. I don't know. It's an interesting thought. I mean, the variation between parts. I've daydreamed about it too, only because some of my job is to replace obsolete components, and when there's not a actual component to replace it, if you actually look at parts these days, and say you have a circuit that does some function, it turns on bit A and that turns off bit B, something actually a lot more complicated than that. But if you go and try and design that in, JFETs or even BJTs or something like that, if you look at a BJT package right now, coming in like a standard package, you're not going to be able to even come close to, because if you look inside the package, then it's actually the leads are then wire bonded to the actual chip, and the actual chip, it looks like a speck of pepper. So, you'd never be able to match the actual size of
right.
what you and
right.
what you and I use for discrete ICs or discrete transistors. You would never be able to use those to build up an op amp in any usable manner at all.
Yeah,
so,
well, I mean, it depends on what your space requirements are. Some of the early op amps were actually made of discrete components, which blows my mind.
They're modules, right?
That completely blows my mind, and I guess it's Phil Brick and those guys way back 40 years ago, I guess. More than that?
Yeah, 69, I think.
Yeah, so they were playing with op amps made out of discrete components. But I agree, to do anything practical and have it be small and anywhere near the footprint of the part you were replacing, I think that's where FPGAs and things like that come in,
right.
because you can do a lot with an FPGA. But if you're trying to do analog circuits, then that doesn't work as well. And that's what led me to start thinking about this Moses stuff, is that there's not really any options for doing integrated analog. There aren't very many analog FPGAs yet.
Right.
Right.
Well, yeah, there's that FPAA, but that thing is not what I like. So
interesting.
I think it'll be interesting because one of the things that really limits people right now, because I think the batch PCBs, what those came from is people going out and buying what used to be high-end equipment, keeping it alive, having a good technician around that can keep it alive, and then pushing technology onto that after the fact, right? So they might go out and buy board processing equipment after the fact, and there is definitely investment there, but it's not as much of an investment as it was when that industrial equipment came out.
Mm-hmm.
The thing about a chip fab, you need so much of it, and I'm not sure how much it actually sticks around because of a lot of the internals of those are actually replaceable. So like inside like a dry etch chamber, it's actually all replaceable parts.
Yeah. Well, I mean, Moses is actually, those wafers are run at TSMC for if you're using a TSMC process. So they actually what they do is they slip the wafers in, at probably 3 a.m. or whatever the equivalent in fab time is. It's probably during their slow season or slow runs. They slip wafers in, so you're actually getting right on the actual equipment. So it's a little bit different than. Well, actually, no, it's not. It's not different because batched PCB, as you might already know, their back end is at Gold Phoenix, which is a real PCB manufacturer.
Oh,
so
I didn't know
they're
that,
not
no.
actually. SparkFun doesn't actually make their own boards, and this is all public knowledge. It's been talked about a lot before. They actually send the boards out. So what they're doing is they're providing a service. So they're panelizing designs from multiple contributors, and then they're sending the panel out because it's not cost effective to get one board made. It's only cost effective if you get a panel, and so they actually panelize them. And that actually reminds me, I actually have a shout out this week, which I didn't think I was going to be able to say, but now that I'm on the show again,
hey, go for it.
I wanted to give a shout out to Dorkbot Portland. For the international guys, this isn't going to be super helpful. I can't imagine the postage is going to be great, although you might want to look at it anyway. There's a really, really helpful guy, and I actually can't remember his real name, but his handle is Lane. And if you go to pcb.lane.org, that's Laen. We can put a link on the site. What Lane is doing is he's actually panelizing boards just like Batch PCB does, but at about half the cost for most small boards. And I actually had some boards made there a couple weeks ago, and they turned out great. So for guys that are looking to do prototypes, it's kind of a cool service, and it's much more targeted towards hobbyists and people that need prototypes for doing stuff at home than Batch PCB is, because it's super low budget, but you pay a lot less to get more boards, basically, is what it comes down to. So it's kind of a cool service, and the reason I'm kind of advertising for it is that one of the things that keeps it going is getting enough contributions to fill PCB panels. And so if there aren't enough people that want to do boards, then the service stops, and then people like me are unhappy.
Right. And he actually was the one, I don't know if you saw that Adafruit post a couple of days, I think you did. It was just the other day about one of the silk screens that was on the most recent order was like some beautiful silkscreen program.
Yeah, so it's because he gets such a diverse set of contributors to the service, he gets some really crazy stuff. And so you end up with boards that have these really ornate silk screens. And the downside is that he's told me that sometimes what will happen is he sends the board in for manufacturing, and the PCB manufacturer will call him back and say, "What is this? Are you sure this is what you wanted to do?" Because, obviously PCB shops are not used to seeing artwork at the level that these boards are on their PCBs. So it's kind of an interesting thing. But yeah, I've seen some really cool boards come out of his service before. So it's really
that's
cool.
Awesome. That's really awesome.
Cool.
And we'll post a link too, so you can get to that. And thanks to, I think it's James actually. I think that's
James,
his name.
yeah, that's right.
So thanks to James. I don't know if he goes by James, but that's his given name.
So hopefully I'm not in trouble for advertising his service on the show, but I just think
our sponsors will be so pissed. We don't have any. So.
Oh, I see.
Yeah, don't worry about that.
I wouldn't do it if I didn't consider this something that's of value to.
That's right.
People
well,
that are doing
the good stuff's got to rise
design.
to the top. So that's a good example of it, and that's good. I'm really glad that he does that. I haven't done it myself. I'll have to try that out.
Yeah, and I don't. He hardly even makes money on the service. I mean, he's doing this just to help people get boards. So it's kind of something he does out of, I don't know, generosity for the community. So it's kind of cool. And I mean, the benefit is that if more people start using the service, he can run more panels, because right now he's running one a month. And so sometimes you've got to wait a little while, but for the price, it's totally worth it.
So have you done it?
Yeah, I have, and the boards are beautiful. I mean, really, really, actually better quality than I've seen from batch PCB. So the boards I got were really cool. One of the funny things is that you don't necessarily know what solder mask color you're going to get, because I guess the guys that are doing the boards just throw these in, just like I was saying, they put them in whenever they have capacity, and so you get what you get. And these came back purple.
Awesome.
Which I've never seen before in a PCB, but it's kind of neat. And I was actually very happy. So I wouldn't advertise the service if I hadn't had a good experience with it, but I was very, very happy with the boards. I've been playing with some USB AVRs, and so I needed boards, and now I've got them. And I got them within 2 weeks, so that was pretty good.
Yeah, you mentioned that last time, so that's going pretty well.
Yeah, it is. Although, like I was saying, the AVR availability is a real killer, and that's definitely impacting me on this design, and it makes it very hard to think about designing more things with AVRs. So that's why I wanted to talk about that, because it's something that affects me on a very real level. Is I just can't get parts. So
yeah. That's too bad. I found the name of the person that was mentioning the IC, making the IC at home. So it was Richard Nienhuis. I'll post his name as well. I think we might have talked about it at home, but he was mentioning that the Intel 4004 was built on 10 micron technology. The 6502 was built on 3 to 5 micron technology. Micron being a micrometer, if you don't know that out there. And he said current laser printers are hitting 1200 DPI, which corresponds to a bit over 20 microns. So maybe give it a couple more years. I don't know if there's any real impetus to move to higher DPI, because I know a lot of documents are still at 300 DPI. So
yeah, that's right.
But maybe it's capable. That's
and I almost wonder. It definitely good luck with that project. But I have to wonder if that is that 1200 DPI really real?
Right.
That's one of those things that I've never believed that for 1 minute.
Who watches The Watchmen? That kind of thing.
Yeah, exactly. I mean, who's actually verifying that 1200 DPI is 1200 DPI? But I say if it's true, then that's pretty killer, and so I guess he's waiting for like the 2400 DPI, because then he'll be right up at the resolutions of some of those old chips. But yeah, if somebody manages to make a 6502 in their garage, my hat's off to them. That would be pretty cool stuff.
That would be cool.
Yeah.
All right, well, I think that's it for us. I know you said you had to run soon, so
yeah, I've got to run, but it was great to be on the show again, and
yeah,
and
thanks for the last minute jump on here.
Yeah, thanks for having me back, and I'm just happy to talk about electronics and happy to be on the show.
And if people haven't, looked at Jeff's site before, it's mightyohm.com. His Twitter is twitter.com/mightyohm. That's how Jeff and I keep in touch, and like he said, oh goodness, I've already forgotten his name again. That's how we talked to James too on there, who goes by Lane. But it's actually kind of cool, and like we've kind of brought up a couple times on this show before about the critical mass, and we mentioned that with Chip Hacker today too. The more people that participate, the richer the experience it is for everyone. So
yeah, absolutely.
Don't be afraid to jump in, and we'll hope to talk to you on there.
Excellent.
All right, cool. Well, Jeff, I'll talk to you soon, and everybody else will hopefully talk to you next week.
All right, sounds good.
All right, bye.
Bye.